Hi, in this video we're talking about pressure and Pascal's law. Pressure has a symbol as P, is force over area. So that will give us the unit in SI will be Newton per meter square. And for US system, that will be pound force per square foot, right? So that's our SI unit in the US system. Now let's take a look. F, we're going to look at the Pascal law. Pascal law has this, that means like a fluid, the pressure at the point is the same at all directions. And this pressure P is rho GH, okay? And what's our rho? Rho is our density of the fluid. And the G we know is going to be 9.8 meter per second square or 32.2 foot per second square, depending on which unit system we're using. H is gonna be the height of the fluid or the depth of the fluid. So think about it. If this is the surface and if you were scuba diving, the further you go down, the H increases. So when H increases, your pressure, your P, is equal to rho GH. That will increase this as well. So in other words, the P increases when the depth increases, right? When the H, I don't use D. Okay. Now, let's think about an engineering example. I mean, often when we drive around the town, we see those water tower. And here is a water tower, for example. And the water tower have certain height. The main purpose of water tower is provide enough pressure so that enough pressure can distribute it to the household, right? So they need, engineer when they design this water tower, they need to know how high they need it in order to achieve desirable pressure. So let's thinking about some scenarios. If we have this height as 100 meter, okay, what will be the pressure then? Okay, so pressure is going to be equal to rho GH. And this rho is this fluid density, which is water. Water is 1,000 kilogram meter cube. And G is 9.8 meter per second square. And our H is 100 meter. Now let's thinking about the units before we put into calculator, right? What would be, I'm going to label that, what would be kilogram times meter per second square, which means kilogram mass times acceleration. That's gonna give us the unit of Newton. And then meter cube canceled out, that's meter square. So what's Newton per meter square? Newton per meter square. That's our pressure. Actually, there's another name for that, right? It's Pascal. So that's going to give a unit of Newton per meter square, and actually we write it as Pascal. So what's this value going to be? So it's 1,000 times 9.8 times 100. So that would be 9.8 times 10 to the power 5 Pascal. And that could be changed to 0.98 megapascal. You could write down like that because 1 mega is 10 to the power 6. All right, so that's scenario number 1. Then if scenario number 2, if this pressure H, you want to increase it, we want to increase to be quite let's see, make to 2,000 meter. What will be the pressure then? We know the pressure will increase, but how much then? We're going to use the same one, rho GH, 10 to the power of 3. 1,000 for water density times 9.8, then times height, that's 2,000. And when we calculate that, the unit we don't need to worry about because you know it's going to get Pascal. We proved it in the previous example. So that's going to be 19.6 times 10 to the power of 6. All right, that will give us 19.6 megapascal of the pressure if we have the height designed the water tower of 2,000 meter. Okay, so that's our pressure and Pascal's law. So remember this new formula, rho GH, if it's the first time for you to see. We're going to use those concepts later on in thermo, beginning of thermo, when we talk about manometer to measure the pressure. Okay, all right, see you at the next one. Bye now.